This is a video for Math 117, Section 2.6. We'll be talking about slopes for pretty much the rest of the semester because the slope is a pretty important concept for calculus. So we're going to look at slopes of secant and tangent lines. So in this first example, we have a graph, a curve here in the blue, and then we're looking at approximating the tangent lines. So they're just barely sitting on the edge there. So tangent lines. So we know we can make an approximation by doing a slope between a couple other points. So if I look here, it looks like the slope of this is going to be the rise over the run. The rise is 7.5 over 5. And the slope here will be the rise over the run, 3.5 over 6. Rise over run. Both of these are going up, so my answer will be positive. If these were going down, I'd have to be paying attention to my answer being negative. Technically, this is negative 3.5 here. This one, negative 3.5. And this is negative 6 because it's running negative 6 from there. So negative 3.5 over negative 6 would give me a positive. But you can see the graph is going up. The tangent lines are also going up. So in general, if we look at the slope of a secant line here between Q and P, and we take that secant line a little closer and closer, Q gets closer and closer to P, we get very close to having the slope of the tangent line. So close to P, the slope of the secant line is very close to the tangent, and as we get farther away, it can be absurdly different. You can see here that the slope of this line is negative because the line is going down. So be aware of when you're on positive and negative slopes. The next question they ask is what is the average rate of change in the average infant's weight over the first year of birth? So the first year of birth would be 0 to 12 months. So I'm going to need a couple of points to get an average rate here. They've given me some points. So I've got a 7.5 for my y and a 22.5. So let's remind ourselves of how we determine that. The slope is the rise over the run. We've already used that on the graph. Or we can do y2 minus y1 over x2 minus x1. Now remember that we can take this equation m equals y2 minus y1 and multiply both sides by x2 minus x1, and we get the equation of the line that we need. This is the point slope equation of the line. Some physics that we're going to look at are average velocity, or the average rate of change, and it's the slope of the secant line. The instantaneous velocity, or the rate of change. If it doesn't say average, it means the instantaneous is the slope of the tangent line. Galileo's equation shows up because we're going to look at some formulas. You won't have to actually motivate the formula, but for those of you who see some physics, you might be interested to know a little bit more about Galileo's here. S naught is the initial position. If it's on the ground, we say S is equal to 0 or S naught equals 0. Anytime it hits the ground, the position, S of t, S, is 0. Anytime on the ground, the position is 0. The initial velocity is the push that you give. So if you're throwing a ball up into the air, you give it a push, it goes up, it slows down, it stops, it turns around, it speeds back up and comes back to your hand or to the ground. V naught is the initial velocity. G is acceleration due to gravity. For Earth, that is 32 feet per second squared, or 9.8 meters per second squared. So you may have seen those numbers before. So back to our graph. We're going to use that formula y2 minus y1 over x2 minus x1. So you need this ordered pair. 12 months, 22.5. 1 month, 7.5. Question number 4 is the effect of bactericide on bacteria. So there's a bactericide A and a bactericide B. So F is bactericide A, and G is bactericide B. What happens to the population if you give the bactericide? So which population is decreasing faster at T1? T1 is here. And decreasing faster means which has the steeper slope. So which one is steeper? So if you're thinking about walking down this slope, which one would feel steeper as you're walking? You can think of it that way. Which population is decreasing faster at T2? They're asking you the same question at 2 different time periods. And then they ask you which bacteria is more effective in reducing the population in the short run. So which one reduced it quickest first and which one is reducing quickest in the long run, or has more effective behavior in the long run. For number 5, I'll just give you a small hint. When you see there's a question down here that asks you when is it decreasing at the slowest rate, that means where is the slope the shallowest. So where is the flattest part of the curve is what it's asking for. So that's a little bit of a trick question, but it's not too bad. For the next few, we're going to use the limit definition of the derivative. We're going to be concentrating on this first one here because your exercise is concentrating on it. So this one you'll need to have memorized for the test, and we'll work through the problem for 3 different problems so you can get an idea of what they're supposed to look like. We go back to what we meant by the derivative. The derivative is the slope of the tangent line to the curve, and we can get it by making the secant line get closer and closer. 2 points form a secant line, so if we take 1 point and take it closer and closer, that will give us the slope of the tangent line, which is what we call the derivative. The derivative is the slope of the tangent line to the curve. I will ask that on the test. So here it is. The derivative is the slope of the tangent line to the curve. Derivatives won't exist at heavy oscillation, jumps, vertical asymptotes, holes, or cusper corners. So we have a lot of problems on the graph for derivatives because it's a limit. So from both sides, the limit has to be going to the same place. So let's do our first one. If we have f of x equals 17, we use the limit definition of the derivative. That means f prime of x is equal to the limit as h goes to 0 of f of x plus h. I'm going to write this again. Minus f of x over h. Now, I need these two things. I need f of x plus h. So that means go back to the f equation. Everywhere I see an x, I'm going to put an x plus h. Well, that is nowhere. So f of x plus h will give me just 17. F of x is also 17. So f prime of x, make sure you write the limit every time until you take it. As h goes to 0 will be 17 minus 17 over h. But 17 minus 17 is 0. So this is just the limit as h goes to 0 of 0, which is 0. As h goes to 0, what happens to 0? It stays 0. So this tells me that the slope of a horizontal line would be 0, because that's what that is. Y equals 17 is a horizontal line. F of x equals 2x plus 8 is also a line, but it's not a horizontal line. We can see the slope is 2, so let's see if that's true if we use the formula. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. I recommend you write it down every time until you've got it memorized, and then even then you might still write it down. So I need f of x plus h, which gives me 2 times x plus h plus 8, and I need f of x. Now you could do this all in one line, so if you're feeling comfortable doing it all in one line, but oftentimes seeing what the pieces look like is a lot more helpful. So f of x is just 2x plus 8. That's what we had to begin with. Y equals f of x. I'm going to expand this, 2x plus 2h plus 8. So we've done these before. I can see if I subtract these off, I'm going to end up with the 2x and the 8 going away. So let's actually write that. The limit as h goes to 0 of 2x plus 2h plus 8 minus 2x plus 8. I don't need the first parentheses, but I do need the second set of parentheses, all over h. So this is the limit as h goes to 0 of 2x plus 2h plus 8 minus 2x minus 8. Now every time we do this formula, part of the whole thing is going to be subtracted off. So part of it's going to go away every single time, and we'll only be left with terms that have h in them. So this is going to give me these going away and these going away. So I'm only left with 2h over h. So this is the limit as h goes to 0 of 2h over h The h's go away. Now I can put h goes to 0 in, and I get the limit is 2, which is not too surprising, because that's 2. Now, if I wanted an equation of the tangent line, that's the next step. Then I need to know my formula for the tangent line. It's y minus y1, well, the formula for any line. Y minus y1 equals m times x minus x1. So I'd have to have a point to be able to do. So equation of the tangent line, let's say at x equals 5. So we need a y1, so that means we need f of 5. So this is my x1. F of 5 would be 2 times 5 plus 8. That's 18. And we have a slope of 2. This is my slope. And it's of the tangent line. So m sub 10 is the slope of the tangent line. So I have y minus 18 equals 2. And I do have to be careful because I just want to put numbers in here all over the place. So be careful with this. X minus 5. So this is my y1 when I get it. So this was a separate one, but not too much of a stretch. Equation of the tangent line. We'll give you one very similar to this on the test, so expected to be able to do a squared. So remember that there's a formula for squares, for perfect squares, because I know I'm going to have to write x plus h. So let's write this. X plus h squared is going to be x squared plus 2xh plus h squared. So you might remember that. Memorizing it will make it better, or you'll have to fold it out every single time. So let's get started. This is what I want to know. I want to know the derivative. So I need f of x, there it is. I need f of x plus h. So it's going to give me negative 3 times x plus h squared plus 5 times x plus h. So I'm just gathering my pieces, minus 7. And then I need to expand all of this. So negative 3 times x squared plus 2xh plus h squared. I can go ahead and multiply this out. This is plus 5x plus 5h minus 7. So then we get negative 3x squared minus 6xh minus 3h squared plus 5x plus 5h minus 7. It only takes a few minutes to write down. It's not too difficult. Now I could take both of these and put them in my formula like this, but I think instead this time I'm going to just get rid of what I need to. I'm taking f of x plus h minus f of x, so this part's going away, this part's going away, and this part's going away. I will ask you to do one of these on the test, so be prepared to do it. So what I'm going to write down is f prime of x. I do need you to write that. You need the symbol there, equals. So I'm going to ask you to find the derivative using the limit definition of the derivative. That's how it'll be stated. F prime of x will be equal to negative 6, well, the limit as h goes to 0, haven't finished that, negative 6xh minus 3h squared plus 5h all over h. Now what I notice is that I have h in each one of these locations here. So I have 1, 2, 3, 4 terms. They all share an h. So I could just go through and get rid of one of the h's. That's the same as saying, let's factor out an h on the top. So I have h times negative 6x minus 3h plus 5. Now the h goes away, and I'm left with the limit as h goes to 0 of negative 6x minus 3h plus 5. As h goes to 0, this part goes to 0. So my derivative is negative 6x plus 5. This is f prime of x. That's the derivative of f of x. And it is a limit. We're taking it from both sides. I showed you the secant and tangent lines. And here my derivative is negative 6x plus 5. This gives me a function that lets me find the slope of any point on the graph. That is the slope of the tangent line to the curve at any point on the graph. So I just showed you an example of what you expect to see for number 6. 7 was a line. 8 was a parabola. 9 is also a parabola. For number 10, if I haven't asked you to do the limit definition of the derivative, then you will just be able to do this quickly in your calculator. So let's look at the calculator strokes here. So to do this in a calculator, to find the derivative, the slope of the tangent line, the rate of change, in your calculator, you'll put your function in y1, you'll do zoom 6, then change the domain if you need to, and a second trace 6, type a number, and enter. So let's go through those steps. So for the first one here, I want the slope of the tangent line to the graph of the function at the given point. So first I need the slope. So I'll put in y equals, clear, negative 3x. Make sure you're putting negative instead of minus, plus 6. I'm going to do zoom 6. And I can see the slope of this line is negative 3, but you may not know that. So if I do a second calc, see the 6 dy dx, it looks like difference in y over difference in x. I want 6. And then it doesn't tell me what to do here, so I need to know that I need to put in the x value, which is negative 1. So negative 1. And when I put that in, it's going to give me dy dx is equal to negative 3. So here's negative 3. So now I need the equation of the tangent line. And in WebAssign, they make you solve for y sometimes. So if I have y minus y1 is equal to m times x minus x1, I know that the slope is negative 3. That's actually the tangent. This I can write as y minus 9 equals negative 3 times x plus 1 minus minus. And then I'll just move that to the other side. Y is equal to negative 3 times x plus 1 plus 9. I do not need you to simplify that, and they don't say to simplify, so you don't have to simplify. So you can just use the point slope form of the line and solve for y. It's pretty easy. They give you a few of these to do, finding the slope of the tangent line. It does not say to use the definition, the limit definition of the derivative, so I can put this straight in my calculator. Now I want to remind you that when you have a fraction like this, the numerator and the denominator have automatic parentheses around them. The 3 you don't really need one, but the other one you do. If you have a TI-84 where you can go to fractions, you can put this in a fraction. That's alpha y equals, and do the fraction, and that gives you 3 over 8x. If you don't have that fraction button or can't find it on your calculator, let me clear out of this, I would do parentheses around the numerator every time divided by parentheses around the denominator, which is 8x. If you leave off these parentheses, the 8 will be divided and the x will be multiplied. So there's an implied 3 divided by x times 8, 3 divided by 8 times x if you don't put in the parentheses. Now if I graph this, I want this at 1, 3, 8, so I have it on zoom 6 already, so if I graph it, I'll be able to take a look at the graph. And I want the slope at x equals 1. So that's second, calc, 6, 1, enter. These are really fast. The slope is negative 0.375. And then you use the same results that we did last time, the same procedure rather that we did last time with y minus y1 to get this. The next few problems are going to ask you to find the average rate of change with y respect to x in the following intervals. Well, the average rate is actual slope. So you'll need y2 and y1. You're given a 6 and a 7, and you're given a y equation. So I have to put the 6 in, and I have to put the 7 in, get 2 order pairs, and find the slope. So I would put this y in, since I'm going to use it several times, into y equals. So we have x squared minus 11x, x squared minus 11x. Second quit. Now I need a couple of y values. I need the y value at x equals 6. And to do that, if you have a TI-84 that has this ability, alpha calc will give you the y1. And then you'll do parentheses 6. That would give you one of the y1s. Now if you don't have that ability, you'll have to do vars, y vars function, y1. y1 of, I'll do 7. the point is to get the y value, and you can just put it in. 6 squared minus 11 times 6, it isn't very difficult to put these in. But they're wanting the average rate of change, which is the secant line slope, not the instantaneous, which would be the tangent line slope, and that's down here at part B. So they are asking for it eventually, but at part B, they're showing you here in part A that to get to part B, you're kind of doing a limit. You want to get closer and closer to 6. So I could do the whole formula all at one time, parentheses y, alpha y1, so y bars, inner. I need a parenthesis of 7 minus vars, y bars, inner, parenthesis at 6, close parentheses, and then close off the numerator. So that's y2 minus y1 divided by, and I'm going to put the x2 and x1 in the same locations as above, in the respective locations. So I have 7 minus 6, which is a little bit of overkill, but I'm trying to make a point of how you can use your calculator to help you get these very quickly. Do enter, and you're done. Now for the second one, I can go up and grab this. Second enter will get you up there if you have a TI-83. And I'm going to go through here and just change this to 6.5. So 6.5 here, I'm going to need to go 6 and do an insert. Above delete, you can see INS, second insert 0.5. I'll do the same thing over here with 7. So that's 6, second insert 0.5. And I'll get the slope. I'll do the last one by going up and grabbing it. Now, if you do second enter like this, it goes up and grabs the formula. So if you only have a TI-83, you still can do this. I'm going to go over to the beginning. I want 6.1. 6.1. Hit enter, and it gives me 1.1. So I can see that the first one was a 2, the next one's a 1.5, and the next one's a 1.1. It looks like my slope is going towards maybe 1. And if I do the second trace, 6 at 1, sorry, at 6, we get dy dx equals 1. So the slope at 6 is 1. I can't really see where that is on my graph because it's down at y equals negative 30. I could do a zoom 0 so I could see it better, but I don't need to be able to see it to get the information out of my graph. In number 14, they're talking about velocity, and velocity, here we want average velocity, which is basically the derivative. It's the derivative, it's the slope. And the instantaneous velocity, which is the slope of the tangent line. So take slope of the secant, slope of the tangent. This is exactly what we just did with 6 in the last problem. So you'll be doing the same procedure, only now you're using y is equal to this. The instantaneous is finding the dy dx. When will the ball hit the ground? Well, you can determine this on your graph when the ball is going to hit the ground. When you draw this graph, you can go out far enough so that you can see exactly when it hits the ground again. So that's the 0. So hit the ground. We'll just graph this real quickly. We have 96x minus 16x squared. And we'll graph it. We get a parabola that looks like that. If I do a zoom 0, I can see a little better that it's going to go up and then it's going to come down. And I'm interested in the 0 right here. So I want second calc 0, that's 2. That's when it hits the ground again. And if you think about it, that's kind of what it looks like if you throw a ball up in the air. When it hits the ground, now though I want the 0 that's over here. So I'm going to put in maybe 4 as my left bound. 4 it says. Enter. So that puts a line to the left of it. And now I want the right bound, which looks like I might be able to put in 8. And you could scroll over. That'd be fine too. And then the guess, it doesn't matter. So we do enter. And it says the 0 is at 6. So x equals 6 is when it's on the ground again. It takes 6 seconds for it to come back to the ground. For number 15, they aren't actually using Galileo's formula. So hits the ground is not the same here. This it says it's from a height of 256 feet, so it's asking when has it gone 256 feet? How long did it take? So 256 feet is going to go in the S, and you'll solve for T. What was the average velocity of the screwdriver between the time of the drop and the time it hit the ground? Well, that's doing the y2 minus y1, putting in 0 for the time it was dropped and the time you just got in part 1. What was the velocity? Well, that's putting this in as the in y1 and then doing the dy dx using that second trace. So we have a hot air balloon rising vertically, and this is certainly not Galileo's because it's not going to be falling. What's the height of the balloon at the end of 31 seconds? Well, h is height, so this means just put in 31, and t is in seconds. What's the average velocity? That's the y2 minus y1 over x2 minus x1. And what's the velocity? Means you're going to put this into y equals and do second trace and your derivative, the dy dx, 6. Number 17 is just the slope between the 2 points. You're going to put in 7, put in 8. You'll have a y2 minus y1 over x2 minus x1. What is the rate? Is the derivative. This goes into y1. You do second trace, 6. On number 18 and number 19, they want you to find these derivatives, so you'll have to use your limit definition to find the derivatives. I know some of you have had calculus before, and when I ask you to do problems like this, if I have not said to use the limit definition, you can use those old formulas that you learned from calculus before. But on this test, I will ask you to use the limit definition a few times, so make sure you're practicing it here. Number 20 says rate of population growth. Put this in y1, second trace, 6, and you have your derivative. That's all it's asking for at t equals 14. For number 21, we have a hole in the graph at A, which is not a problem for limits. And you can get on the graph and travel there. From both sides, it's going to the same place. And we say what that place is. It's not the function value because there's a hole there. It is not continuous because there's a hole there. If there's any problem on the graph at all, there's a hole. If it's not continuous, then it can't be differentiable. So we have problems about differentiability. I mentioned those earlier in this video. And hole is on that, so it's not different. Note that there are no problems on this graph. So no problems means everything's nice. There's a jump on this graph, so nothing's nice at A. Nothing works at A. There's a vertical asymptote on this graph, so nothing works at A for a vertical asymptote.